Pretend it didn't say greater than or equal to. Pretend it didn't say less than. Just pretend like it said equals. Okay? The related equation is this guy, x minus 5 times x plus 2. But this time it just equals 8. Okay? And the solutions to this equation are going to be something significant regarding this inequality. We'll get there in a second though. Okay? But just pretend like it's equals. And on your test, I want to see where if you put equals. Okay? If you don't put equals, if you leave it as greater than or equal to, there's a high probability that you're going to confuse yourself about something and you're going to think that something's true that isn't true. Okay? So just call it equals. Alright? Make it easier on yourself. If I call that equals, well then what kind of equation is this? And how do I solve it? This is a quadratic equation, but I gotta get it in standard form and all that mess, right? So I'm gonna have to distribute, or not distribute, but multiply this out. So that's x squared, minus 5x, minus 10 equals 8. So that's,
How did you do plus?
my FOIL?
Oh, no.
Yeah, you skipped that step. You already called that minus 3x, combined your like terms. And if I subtract that 8 over, it's minus 18 equals 0. And hopefully that factors, does it?
Yeah.
Okay, cool. So if it factors, we have x minus 6 times x plus 3 equals 0. And I get from that x equals 6 or x equals negative 3. Okay? But those are not my solutions, necessarily. Okay? Those are what we're going to call critical numbers. Okay? Use critical numbers and make a little asterisk there because we're going to have a footnote here. Use critical numbers to set up test intervals. The reason I got a little footnote here is because there's two ways to get a critical number. Okay? Critical numbers are, not one, we need one. Let's say either solutions to that related equation. Okay, what we just found, those are critical numbers. And the other way to get critical numbers are values that make denominators 0. So as a footnote to this problem, we didn't have any of those kinds of critical numbers because we didn't have any denominators worth considering, right? So our only critical numbers for this kind of inequality are those solutions to the related equation. Okay? But on the next problem, I'll show you that these are also critical numbers and how to get them. They're actually, for the most part, easier to find. Okay? So, test intervals. What do I mean by that? Well, we're going to take our number line, just our real number line. And I'm just going to label those. Let's see, negative 3 would be over here somewhere. And 6 would be over there somewhere, okay? So if I take my number line and I split it up into those 3 chunks, I've got this one chunk of all the values that are less than negative 3. I've got this chunk in the middle here representing all the numbers in between negative 3 and 6, and this third chunk is everything bigger than 6, okay? The reason we call them test intervals is we're going to pick a representative from each one of these intervals. We're going to plug it into the original inequality, and whether we get a true or false statement out of that is going to tell me whether that number and all those other numbers in that interval are solutions or not. Okay? It's like, and this is a ridiculous example, but what we're going to do is imagine somebody's like walking around the halls taking surveys of classes, and this guy pokes his head in this room, and he asks Jillian, is this a college algebra class? And she's going to say yes. And that person is going to safely assume that all the rest of y'all are also in this college algebra class, right? He's not going to ask every single one of you are you in a college algebra class. He's going to take Jillian's word for it that if she says this is a college algebra class, then all of y'all are in a college algebra class, okay? So ditto here. With the actual numbers, we're going to pick something over here, any number less than -3. It doesn't matter what. Okay, does anyone have a favorite number less than -3? -4. Okay. It's kind of unimaginative, but why not? So if I'm using -4 as a representative for that whole interval, then when I take -4 and I plug it in, do I get a true or false statement? Let's see, -4 minus 5 is -9. -4 plus 2 is -2. Is that greater than or equal to 8? What's -9 times -2? 18? Is 18 greater than or equal to 8? True? So here's the thing. Was -4 a solution? So that means every other number that's less than -3 would be a solution as well. If you don't believe me, try them. You have infinite choices. Try them all if you want. Take any number over here, plug them in. They're going to work out. So I'm going to shade this interval here to say all of those numbers that are less than -3, they end up being solutions. Okay? Did y'all want to try any other numbers? How about -1 billion? Yeah, let's try it. If I take -1 billion and I plug it in, -1 billion minus 5 is what? -1 billion-ish? And -1 billion plus 2 is still like -1 billion-ish? And if I take a -1 billion-ish times a -1 billion-ish, I'm going to get a positive, very large number, right? Billion squared-ish. And is a billion squared-ish going to be bigger than 8? If I give you the choice between $8 and a billion squared dollars, it's an easy choice, right? So, every number. Did y'all want to try any other numbers? I think it's all going to work. Okay? So, every single one of those numbers ends up being solutions for that inequality. So then, we go to the next interval. We pick any number in between -3 and 6, but you better pick 0. Okay? When 0 is a choice, it's like the easiest choice. We can plug in 0 for stuff, like stuff drops out easy. Okay? So if I'm taking 0 and plugging that in, just as a representative for all of those numbers, then 0 minus 5 is -5. 0 times +2 is 2. Is that greater than or equal to 8? No. -10 is not greater than or equal to 8. That's false. So was 0 a solution? No, and neither would any other number in that interval be a solution.
Do you want to run that?
Oh no, I'm just making, I mean, you don't have to. No. But I'm just making up a little visual that it didn't work. Okay? So then finally we pick any number bigger than 6. Your favorite number bigger than 6. 10? I like 10. Good choice. Why'd you pick 10? Because my birthday's the 10th?
No.
So you should have said yes.
Oh, yeah.
Yeah, okay. That's right. Coming this December 10th, I'm going to have a birthday this year. Okay. Now, we're out of school, so you guys don't have to worry about getting me a present or anything like that. But I will say this. Are any of y'all thinking about graduating this semester? Yeah? Graduation is on December the 10th, and I have to go. So if you graduate and go to your graduation, like, you know, after y'all can all buy me a margarita or something. Right? For my birthday. Okay, so 10. Excellent choice, Alyssa. Billion would also have been a good one. Or 6.1, but 6.1 would have been a great choice. It's just been an okay choice. If I'm plugging in 10, 10 minus 5 is 5. 10 plus 2 is 12. And that's way bigger than 8, isn't it? 60? So 10 works, 6.1 works, 6.001 works, 1 billion works, 1,003 works, all those kids work. Okay?